Hello all and welcome to this AWS tutorial on DynamoDB. In today's tutorial, we will see how to create a DynamoDB table, how to insert items in a DynamoDB table, how to scan and query our DynamoDB table. Let us see what is DynamoDB. So DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. DynamoDB allows you to create a database table that can store and retrieve any amount of data and serve any level of request traffic. Its flexible data model and reliable performance makes it a great fit for mobile-based application, web-based applications, gaming applications, edtech applications, IoT applications. You could potentially use DynamoDB for any other application as well. For our tutorial today, we will be creating a DynamoDB table using its default read-write capacity units. The default read-write capacity units for DynamoDB is 5. So we have 5 read capacity units and 5 write capacity units. Let us understand what is a read capacity unit. A read capacity unit represents one strongly consistent read per second or two eventually consistent reads per second for an item up to 4 KB in size. Item sizes for reads are rounded up to the next 4 KB multiple. For example, if I am reading a file which is of size 2.5 KB, it will consume the entire throughput of 4 KB even though it is lesser than 4 KB. And the reason behind it being is that one read capacity unit is of size 4 KB. And any other unit, let's say if you add more units to this as well, each unit is of size 4 KB. That means the first unit is of 4 KB, second unit is of 4 KB. Hence, if I have 2 read capacity units, I would have a total size of 8 KB. You cannot reduce this size. Okay, so even though your item size is lesser, it will still consume the entire throughput of 4 KB. Let us now understand what is a write capacity unit. A write capacity unit represents one write per second for an item up to 1 KB in size. Item sizes for writes are rounded up to the next 1 KB multiple. So for example, if I am writing an item which is of size 500 bytes, it will consume the same throughput that an item of size 1 KB would consume, even though it is half the size of 1 KB. Again, just like the read capacity unit, the write capacity unit is provisioned in multiples of 1 KB. So let's say if I had an item which was of size 2 KB, then it would provision 2 write capacity units. But let's say if I had another item which was of size 2.5 KB, then it would provision 3 write capacity units of size 3 KB. Remember, it's in multiples of 1 KB. Although my item size is 2.5, it will still consume the entire throughput of 3 KB. Now, I will be creating a separate video on how to calculate read and write capacity units for your DynamoDB table, depending upon your item size and the number of items that you read or write per second. Okay. At this point of time, for this particular demo, we will just go ahead with the default read-write capacity units. After we have created the table, then we will add records or items to our table. Finally, after we've added items, we will scan our table and then query our table. So let me quickly switch to my AWS console. So this is my AWS console right here. And I'm going to switch to DynamoDB. Okay. And let us click on create table. And I'm going to create a table over here called as orders. So the table name is orders. And I'm going to give it a primary key called as order ID. And I'm going to make it a numeric key. Now, as I mentioned earlier, we will be using the default settings of DynamoDB. So as you see, it has a minimum of 5 read capacity and 5 write capacity units. So let us go ahead and click on create. And as you see, our table is currently being created. So once our table is created, then we will go ahead and add items to our table. So as you see, our table is now created. This is our table name, orders right over here. This is our primary partition key order ID, which is numeric. We have disabled point-in-time recovery, encryption, time to live. Our table status is active. The provisioned read capacity units is 5, same as the write capacity units, again 5. And currently there are no items, and the storage size currently obviously is 0 because there are no items. Okay, so let us go ahead and now add items to our table. So click on items and then click on create item over here. So as you see, our primary key is order ID. So I'm going to give it an order ID over here as 1. And then I'm going to add a couple of more columns. So let's say I'll add another column over here, which is of type string, and I'm going to call it as order, let's say order name. Okay. Let's say I'm going to say this is NAM's order. Okay. Then we will add one more column to this, let's say of type, I'll say list. Okay, so we'll say order items, and we will add something over here of type, I'll say string. So I'm going to say, I'll give it something like soap. Okay, add one more item, string, and I'm going to say maybe, okay, I'll just say maybe paper, something like that, maybe. Okay, I'm just going to say toilet paper. Okay, and so we've added a couple of items over here. Okay, so I'm going to go ahead and now click on save. So as you see, our first item record was created over here. So let's go ahead and create one more item. So I'm going to create an item with item order, item ID as 34. And again, we will go ahead and append a string. So this time I'm going to give it order date. And yes, and when it comes to DynamoDB, you can have different kinds of columns. Okay, so we are going to give it the date as 11th November 2018. Okay, and let's say I'm going to give this a value over here. So is it order status? Okay, so let's give it order status, and the Boolean value is true. Okay, so I'm going to go ahead and save this. So as you see, our columns for our first order and our second order are different. Okay, so let's create one more item. We are going to give this order number as 700. And I'm going to add, say, order name again. I'm going to say general order. And then I'm going to say again, let's say Boolean over here, order status, and I'm going to give value as false. I'm going to go ahead and save this order. So we've created 3 orders over here, as you see, with order ID 1, 3, 34, and 700. And these have different types of columns. So this is the beauty of DynamoDB, right? It's a NoSQL table. So you could potentially have different kinds of columns over here, and you could have different values in them, as you see. So this is great. Okay, so let us now go ahead and scan our table. So in order to scan our table, remember the scan table actually scans the entire table. If you want, you can add filters. So let's say I'm going to go ahead and give, say, order name, and it says it is string, and let's say contains order. And now we're going to click on start search. So it will basically give us all the orders which have order in its name. So let us click on start search. Okay, so there is nothing that matched. Okay, let us say equals nam. So let's see if this research sends. Okay, nothing still. Nam's order is looking for a specific match. Okay, still nothing. Okay, there you go. So that was my mistake over there. It should have been, I had the wrong column name. So I'm going to go ahead and remove this and then go back to my original query. So order name. So yeah, it is case sense. It is basically if you have space or anything in between, it is sensitive to that. Okay. So now let us go and click on start search. So we got our two orders as expected over here. So NAM's order and general order. Okay, so a couple of things to keep in mind, guys. Whatever order or the column name that you give over here, ensure that you have the same name on the top. If you give a space over here, it is not going to match it. Okay, so this was a scan. So you can pretty much give any kind of filter if you want to. If you don't want, then it is basically just going to go ahead and scan the entire table. So if you just click on start search, as you see, it scanned the entire table and it returned us all the 3 records. Now let us go ahead and query the table. So if you click on query over here, so as you see, if you query a table, you have to provide a value for primary key, and that is because how the query table works. The query table basically goes and searches for records that match the primary key. It looks for that particular record, compared to scan, which actually scans the entire table. So it basically picks up all the records in the table and then applies the filter expression on it. Versus query will only pick up records that will match your primary key value. So let's say if I'm going to give a value over here as 33 and start search. So we don't have any records for 33. Let's say if I give 34 and click on start search, then it will return me the record where the primary key value is 34. Now, if I want, I can certainly add additional filters over here. So let's say attribute, I'm going to say order status is equal to false. Okay, so click on start search. Again, we don't have any records wherein the order ID is 34 and our order status is false. So if I change this to true, then our record should show up. So order status is true. Okay, so now it should show up. Okay, why is it not showing up? Boolean. Okay, so again, I had the wrong type over there. So click on start search, and there you see our order status showed up. So this is our record right there. So keep this in mind, guys. You would need to ensure that the column name is the same as the column name over here. No, don't have any spaces or anything of that sort. The column type also should match. So if you select this as string or number, it's not going to work. And again, the value should match accordingly. So this was our, a little example over here to scan our table and to query our table. Now I have created a slide wherein we'll basically compare and contrast and understand what is the difference between scanning a table and querying a table, and versus what are the similarities as well. So let me switch back to my PowerPoint presentation right here. So this is a small table over here as I was talking. So scan operation, as we saw as well, reads every item in a table or a secondary index if you have a secondary index. Versus a query operation finds items based on a primary key value. Hence, if you remember, if I switch back over here for query, we have to provide a primary key value. If you don't provide, it's not going to go further ahead. So let me remove this and let's if I go down and click on start search, you saw it gave me an error over here saying that this value is empty. I have to enter a value. So if you have to perform a query, then you have to provide a primary key value. It's mandatory. But let's say if I change this to scan, then this will disappear. And as we discussed, this will just scan the entire table. So again, by default, a scan operation returns all the data attributes of every item in a table or index. So if I just go ahead and click over here on start search, it is going to return me everything. As you see, all attributes of all items are returned. Okay, now you can query any table on a secondary index or a composite primary key. It really doesn't matter. But when you're performing a query, it will basically only pick up records where the primary key value matches. And if you've provided filter expressions, then it will filter out that and it will provide you only what matches after filtering everything. Okay. Now you can use projection expression parameter so that the scan only returns some of the attributes rather than all of the attributes. So that is a possibility, but by default, it is just going to go ahead and return you all the attributes of all the items. Due to this above reason, scan operation or performing a scan operation on any table in general is slow, and it's especially slow for large tables. Okay, so this is very, very important. Keep this in mind, especially if you, let's say, if you go for an interview, they can ask you what is the difference between scanning a DynamoDB table versus performing a query on a DynamoDB table, and should you even perform, scan operations on DynamoDB? I mean, you can perform if you really need to, but otherwise, it is typically not recommended to perform scan operations on DynamoDB table. As we saw, it actually performs a scan on the entire table first, and then it applies the filter expression to filter out what you have requested for. Vis-a-vis a query will only pick up items that will match your primary key value. Okay, so by default, the read consistency for both scanning a table and querying a table is eventual. If you want, you can set the consistent read parameter to basically true, and that will change the read consistency to strongly consistent. And that is true for both when you perform a scan table and a query table. The default result set size is 1 MB for both scanning a table and querying a table. Again, as far as the filter expression is concerned, the filter expression is applied after a scan finishes. That means when it scans the entire table, after that, the filter expression is applied. But before the results are returned to you. So it scans the table, then applies the filter expression, and then it returns the result to the caller. Okay, so therefore a scan will consume the same amount of read capacity regardless of whether a filter expression is present or not. A filter expression for query is applied after a query finishes. So let's say you had filter expressions in your query. Remember, a query only picks up items based on the primary key value. So once it has picked up those items that matches the primary key, after that it applies the filter expression on those items. And then after applying the filter expression, then the results are returned to the user or the caller. Therefore, a query will consume the same amount of read capacity regardless of whether the filter expression is present or not. That is because it first gets your items which match your primary key value, and then it applies the filter expression on that. So hopefully, guys, this was helpful. I tried to cover some basics for DynamoDB in this particular tutorial. And some of these things are extremely important, so ensure that you feel free to pause the video, read through this table in detail, especially if you're preparing for an interview. It will help you to answer some of the questions thoroughly well. Okay, so that's it from me, guys, for today. Hope you like this video. Please feel free to provide your comments, and if you want me to create videos on any specific topic, have it posted in the comments, and I will try my best to have those videos created for you. Thank you, and have a nice day. Bye-bye.